In the Modules tab, select the Photo mode. You can choose from several maps with different missions. Select a map and left-click on it. On the right, you'll see the mission description. Study it carefully. The specifications listed there will be needed and used to configure the drone's camera. Select a suitable drone from the Quick Selection panel or through the More Choices section, where drones are listed with detailed specifications. Important! You'll need to use the drone's camera specifications, sensor resolution, and focal length when creating an autonomous flight. These specifications vary from drone to drone. Select a drone. Launch the mission and wait for the 3D flight simulation window and the Q ground control application to fully load. You're already familiar with Q ground control in manual mode. Now let's create an autonomous flight. You'll need to correctly configure the drone and its gimbal parameters. Click Plan and then File. If you have an old flight plan loaded, click Clear to clear it. We set the mission start parameters. We set the altitude calculation mode based on the ground over which the drone will fly. To do this, select Calculated Above Terrain in the All Altitudes line. First, we'll plot an autonomous flight route to explore the area according to the mission. Click the takeoff icon. Set the initial takeoff altitude. Click Waypoint and select a location on the map for the point where the drone will fly before beginning the pattern flight. It's important that the maximum flight distance from one point to another must be less than 900 meters. We set the speed at which the drone will begin the mission. Speed affects the quality of the resulting images. For high-quality aerial photography, the speed should be set lower than the default. Let's create a pattern for exploring the area. Click the pattern icon and select the desired value in our chosen mission, its survey. The easiest way to select the area is using the Trace tool. Make sure the entire desired area is within the flight zone and adjust the positions of individual points if necessary. Click Done Tracing to proceed to the survey settings. If the mission specifies coordinates, you need to enter them for each surface point. To do this, click on the point whose coordinates you want to change and select Edit Position. A panel will open on the right where you need to enter the latitude and longitude. To apply the new values, click the Set Geographic button. The point will change its position according to the entered coordinates. Now you need to configure the camera parameters. Go to the Cameras tab, select Custom Camera, and set the values according to the mission task and the selected drone. For ease of entry, resize the windows so that all the parameters you need to set are visible. Set the sensor size, resolution, and focal length. If any values are missing from the drone description, you should find the correct values on the drone manufacturer's website or calculate the focal length yourself based on the equivalent focal length. The area being studied has different altitudes. To allow for changes in the altitude value, use the tolerance value. We set the tolerance for the altitude value. We set the image overlap according to the task. We set the flight altitude in one of two ways. The first is by directly setting the altitude, while the second, more accurate, is by setting the GSD value, which stands for ground sampling distance. This is the image resolution, indicating the real-world size of 1 pixel on the ground. After setting this value, flight altitude will be calculated automatically. We set the angle. If necessary, we can change the entry and exit points using the Rotate Entry Point button. Once the settings are complete, press the Return button to return and land the drone at the starting point. Our flight task is now complete. Upload the flight task to the drone and press the Upload Required button. Switch to Fly mode, wait for the Ready to Fly status, and then execute the flight command. Confirm the execution of this command. Wait for the flight to complete. Since the drone flies at a relatively slow speed to capture high-quality images, completing an aerial photography mission requires a significant amount of time. After landing, the drone will display a result with an indicator that shows the quality of the aerial photography. You can analyze your work. Go to the Statistics section, where your flights are displayed, and save the resulting images. To do this, hover over the mission status. Click on it, and in the window that appears, click the floppy disk icon. Then, select the destination directory for the images and wait for the data to be saved. You can work with these images in third-party software, such as those for constructing 3D terrain models or creating orthophotos.